Welcome to Archiversity online classes. In this lecture, I am going to explain you the concept of paid samples t-test. I'll also explain you the uses of a paid sample t-test and the context or situations where we can use paid samples t-test. Then the assumptions that we make in running a paid sample t-test, and also how to frame the hypothesis. Finally, instead of focusing on the formula-based calculation of paid sample t-test, I'll show you how to run a paid sample t-test in IBM SPSS and also interpret the result. That means whether the hypothesis testing is done or not, whether we need to retain a hypothesis or reject the hypothesis based on a statistical significance value is also explained in this lecture. We use paid sample t-test when we are interested in the differences between means of two related measures. If you're looking at the two related measures, then we use a paid sample t-test. In the paid sample t-test, each case is associated with two scores that may represent either two different variables. One is that it represents two different variables, or the same variable measured at two different points in time. So when you are saying that two different variables, suppose an individual is there, let us say an expert of a product, and he will be given to make a comment on advertising 1 and advertising 2 of a company, and expert opinion, expert 1, expert 2, expert 3 opinions are sought. So this is individuals are 1, but they are going to give you a rating on a two different variables. This is one way. Or other way, that two different points of a time. Let us say we measure a response from the Jan and Feb, where the respondent will be the same. So from same respondent, respondent 1 will take data at a two different points. Similarly, respondent 2 at a two different points. So in these situations, you are pairing them. So that is the reason why we call this as a paid sample t-test. Now here we have a written explanation here. We call this as a paid sample t-test because two measures are linked or paid for each case. Now probably the more common application of paid samples design is pre-test and post-test. So suppose a company designed a website, and before running it, it will collect the data, or it will collect the opinions from the participants. Then after getting a feedback from the participants, it's again after some time it makes a design changes to the website and again go back to the customers and seeks their opinion. So that is a pre-test and post-test. So many examples are there in a business where we come across with a pre-test and a post-test. So in such scenarios, the popular method is paid sample t-test. So this is also known as a measures or within the subject's design. And the paid sample t-test explicitly uses Pearson correlation between the measures. Now, what are the common uses that we use paid sample t-test, or the scenarios where we use paid sample t-test are that to find out or to test statistically difference between two time points, or to find out statistically significant between two different conditions, or two different measures, or difference between a matched pair. So in all these scenarios or contexts, we use paid sample t-test. Now when we're talking about a paid sample t-test, the test can only compare the means of two, that is only two. So it need to be only two times, whether it is a two variables or it is a two different points of time or two measurements or two conditions. It is a very important criteria for running a paid sample t-test. Now the paid sample t-test is not appropriate. When I am saying that not appropriate, in which conditions we may not be able to use a paid sample t-test. One is that if your data is unpaid. So if your data is unpaid, then you need to go for an independent sample t-test. Now comparison between two or more units are there. So as we are saying that in a paid sample t-test, we need only two variables. If there are two or more groups, then you need to go for analysis of a variance. And the third one is that a continuous outcome that is not normally distributed. So if data is not normally distributed, that is your dependent variable is not normally distributed, then you need to transform the data by using this one different mathematical procedures, then run, or you can go for a non-parametric statistical test. Now fourth is that an ordinal or a ranked outcome, that is if your dependent variable is measured on an ordinal or a ranked outcome, in such case it is advisable to go for a non-parametric statistical test. Now the hypothesis that we frame in paid sample t-test is that the null hypothesis is that the paid population means are equal. The population means are, that is the paid population means are equal. So this is null hypothesis, and your alternative hypothesis is that it is not equal, means are not equal. So here M1 represents the population of variable 1 and M2 represents the mean of a population variable 2. Now I'll show you how to run paid sample t-test using IBM SPSS. So here is the data. This data belongs to a randomly chosen listed companies in India. And here you have a Q1, Q2, Q3, Q4. This indicates quarter 1, quarter 2, quarter 3 and quarter 4. 4 quarters net profit margins of randomly chosen companies listed in Bombay Stock Exchange of India. So randomly we choose the 27 companies. Now we are interested to know whether there is any relationship between net profit margins earned by a company during a quarter 1 and quarter 4. You can make other comparisons also, like whether the mean returns, that is mean net profit margin of a quarter 1 and quarter 2 are same, or quarter 2, quarter 3 or same, quarter 3, quarter 4. But as we are running a paid sample t-test, at any point of a time you can take only 2. So for now what I want to do is I want to run a relationship between Q1 and Q4. That is because Q1 is a quarter 1 is the beginning of the year and Q4 is the end of the year. So is there any relationship between average net profit margins earned by these sample companies during a quarter 1 and quarter 4? So first what is that we need to do is we need to check for the normality and outliers. So for that, go to analyze, then descriptive statistics, click on explore. Now we are saying that a Q1 and hold the control key and select Q4, send them to dependent list, and here statistics, go for outliers, then click continue, then click on a plots, then uncheck the stem and leaf, and to make this very closer we select dependents together instead of a factor level together. Look at the dependents together, then go for a normality plots with the test, then click continue push button, then click OK button here. So here the purpose of exploring this is to know whether the data is normally distributed or not, and next is that whether there are any outliers, because these are the two important assumptions of a paid sample t-test. So here we look at the skewness values and kurtosis. Skewness value is -1 and kurtosis is 2. Then similarly you have a mean values, skewness is -2 and kurtosis is 12. So you have a extreme values and tests of a normality. As your data is large, automatically this Kolmogorov-Smirnov test and Shapiro-Wilk test shows you the significant value only. However, at 99% confidence level, we retain the null hypothesis. Here are the QQ plots, then retended plots are here. Just we are interested to look at the outliers. So there are certain outliers also here. So in case of a Q1 and in case of a Q4, there are outliers. So as such, with this data, you will not be able to run the paid sample t-test because there are outliers and the data is also not normally distributed. Now what is that you need to do is you need to weed out the outliers, then transform your data so that your normality assumptions are met. Okay, this is one. So as on this format data, we will not be able to run the paid sample t-test. So what is that I am doing is we make corrections to this, and now here is the data which is modified. So now we run a paid sample t-test, go to analyze, then go to compare means, here paid samples t-test. So the paid sample t-test, what is it we want is, we want to compare fourth quarter with the first quarter, whether there is any improvement in a fourth quarter results, or the difference between fourth quarter and first quarter are same or not. So we'll check the quarter 4 and send it to variable 1, then choose the quarter 1, send it to variable 2. Here in options you have a percentage, click continue, then click OK. So here you have a test statistics and a paired correlation. Correlation is 0.77 and significance value is 0.00. We can say that there is a significant positive correlation between these two. Look at the paid sample t-test output here. So the mean is here, standard deviation, standard error, degrees of freedom, and significance value. The significance value is 0.311, which is greater than 0.05. So we retain the null hypothesis, indicating that there is no significant difference in the average net profit margins of these selected companies of a first quarter and a fourth quarter. That means the mean net profit margins of first quarter and a mean net profit margin of a fourth quarter of these selected companies are same. And similarly, if you look at the correlation also, statistically significant, in the sense for both the time periods, the values are more or less same. So this is how you need to frame the hypothesis. Then first run the explore to check the outliers and normality. And if you find any outliers and there is an deviations in a normality, then you need to weed out the outliers, transform the data so that the normality assumption is met. After doing that transformation process, then you need to run the paid sample t-test using a compare means and interpret the result. So for our example, we can say that there is no significant difference in the average net profit margins of the select companies during fourth quarter and first quarter. That is the result which we are making from this analysis. Thank you for listening to the lecture.